Okay, so we're starting chapter 4, and this chapter is on regression analysis, exploring associations between variables, and some of the things we're going to be talking about, exploring associations between numerical variables graphically and numerically, and model linear trends using a regression line. In chapter 4.1, actually, we're going to just examine the scatter plots to investigate association between numerical variables, not create. So a scatter plot is the primary tool for examining relationships between two variables. Primary tool for examining relationship between two variables. Each point on the scatter plot represents one single observation. So usually created using technology such as computer program or graphing calculator. Here are examples of a scatter plot. Each point on the scatter plot represents one state in the US and the District of Columbia. Each point represents the median age of marriage for men and women, and each data point has the form median age of women, median age of men. So every single dot on here represents the median age of women and the median age of men as a point in the point form. In other words, an X and Y point. Now, when you look at scatter plots, there are three features that you have to consider. The trend, like the center, the strength, like spread, and the shape. Okay. The trend, the general tendency of the scatter plot as you read from left to right. Typical trends, if the graph is increasing uphill, it's called a positive association. In other words, if that line kind of has a positive slope, for those of you who have an algebra background, or it's increasing as you move from left to right, it looks like this, that way, then we can say that it's called a positive association. And if as you move from left to right, it's going downhill, it's called a negative association. And there is no trend if there is neither uphill or downhill trends observed. Okay, so keep that in mind. This scatter plot shows a positive trend because the graph grows uphill. This measures the age of the car, and it says this means that the age of the car increases, then the mileage also increases. Note that the trend is roughly positive going that way. Okay. Here's an example of a rough negative trend. The scatter plot shows a negative trend, and it's a plot of literacy rate versus total births per woman. The scatter plot shows a negative trend. It's kind of trending that way, as downhill from left to right. This means as literacy rate increases, total births per woman tends to decrease. Remember, these were just examples, and the surveys are not intended to mean the general description of our current population. Okay, they're just used as examples. Okay. In this particular case, there's no trend observed. There just seems to be a big cluster of data in the middle of the graph. This is the scatter plot for years. For every age group, we can find relatively fast or relatively slow runners. Okay. Marathon running speed does not seem to be related to the age of the runner, and this is generally true, yes. Uh, so here's another example. Uh, in this case, the trend is neither positive or negative, but it cannot be correct. Although this data shows an association, it's not positive or negative. It changes from negative to positive. Okay, it changes from that way to that way. So it's neither negative nor positive. Next, we can speak about strength of the association. And actually, in chapter 4.2, we're going to talk more about this. Scatter plots with large amounts of scatter or vertical variation indicate a weak association. Scatterplot with small amounts of scatter or little vertical variation indicates strong association. So let's look at some examples of this. Here is an example of the height as related to weight and the waist size as related to weight. Is there a stronger association between height and weight or between waist size and weight? So observe, this is, very little change. It's trending that way. But this one is more scattered. So there is clearly a stronger association between waist size and weight. And they go on to explain that there seems to be a strong association between waist size and weight because there's less vertical variation here. It's trending roughly along the same. This is more spread out. Okay. Oops. Next, we're going to discuss the shape. Scatter plots that cluster around a line models linear trends. This scatter plot shows that there's a linear association between volume of searches for the word vampire and zombie. Notice, like, you can put a rough line through the points. A nonlinear example would be something like this, where sometimes there are trends in data that this scatter plot shows that there is a nonlinear trend between temperature and pollutant in the ozone levels. It's kind of curving and not, you can't really put a straight line to it and feel good about it. When writing descriptions of association between two numerical variables, always includes trend, shape, and strength. In addition, mention any observations that don't fit the general trend, if any. So here we can describe association. This is, how would you describe the association between the median age of marriage for women and the median age of marriage for men in the 50 states and the District of Columbia? So take a look at this, and then let's look at how we would describe this. The association between median age of marriage for women and median age of marriage for men is positive and linear. In other words, women who marry at an older age tend to marry men who are an older age. This association is strong because there is very little vertical variation in the graph. All right, things to be careful. Always use phrases like tends to when describing an association, because the trend that you're describing has variability. The association you're describing has variability, okay? The association you'll be describing may not be true for all individuals. And then, secondly, always point out any data points that appear to be unusual or not part of the pattern. And we remember these are called outliers. So we're going to go ahead and take a look at our homework for this section. I'm going to discuss some of the problems with you, not all of them. So in this homework, we're actually going to just examine different graphs and draw conclusions as best as possible from what we have. Here's question 1. Both figures below concern the assessed value of land that includes homes, and both use the same data set. Complete parts A and B below. Which do you think has the stronger relation with the value of the land, the number of acres of land, or the number of rooms in the house? So acreage versus the value of the land, and rooms versus the value of the land. Clearly, this one has stronger association because it's more clustered together, very little variation from the straight line going up. This is more spread out. So the number of acres has stronger relation, and there's 2 examples that have the number of acres, but the fact that the points are less scattered in the vertical direction would make a lot of sense. If you were trying to predict the value of a parcel of land in this area on which there is a home, would you be able to make a better prediction by knowing the acreage of the number or the number of rooms? Explain. So we've already concluded that acreage shows a stronger relationship with the value of the land. So we're going to go with the acreage right here, because the association is stronger between the value of land and acreage with the number of rooms, because the vertical is less spread, and it's actually the same type of answer for part A. I'm not going to answer this one for you guys. I'm going to leave it. You guys should be able to figure this one. But all right, let's talk about it. The figure shows a scatterplot of the age of students and the value of their car. Does it show an increasing trend, decreasing trend, or changing trend, or very little trend? So notice the trend is going from positive to negative. So I would go with changing here, but I don't know. You guys might want to think about something else, so you figure it out. Okay, but I would say this is a changing trend. Figure shows a scatter plot of shoe size and GPA for some college student. Does it show an increasing trend, a decreasing trend, or no trend? So it's going uphill. It shows clearly an increasing trend. Increasing. I'm trying to pick from the words here. Since the points show an increasing pattern from number 2. When you go from left to right, the graph is doing that. Okay. The relationship is strong because the points show consistent and small vertical spread. It's not really spread out that much. The scatter plot shows data from 50 states taken from the U.S. Census, the percentage of the population 25 years or older with a college degree or higher, and the median family income. Describe and interpret the trend. So to me, this looks like it's trending positively as we go from left to right. There are two answers that have positive, this one and this one. So we have to kind of describe what it's saying. The first answer says states with a larger proportion of college education, right? As the college educated people increase, the the median family income is also increasing. So I would go right away with this answer. I don't even know what the second answer says, but I would go right away with that one. You know, as as college educated people increase, the higher median family income increases. The scatter plot shows the number of work hours and the number of TVs per week for some college students who work. There is a very slight trend. Is this trend positive or negative? So it's roughly negative that way. Yeah, it's roughly negative. What does the direction of okay, so first we know the trend is negative, and the more hours, work hours a student has, the fewer hours of TV they would tend to work. Okay, so yeah, this one. The more hours of work a student has, the fewer hours of TV they watch. Now, continuing, says to identify any unusual points. Here is an unusual point, 70. Select the correct choice below, and if necessary, fill in the answer. So the person who works 70 hours appears to be an outlier because that point is obviously separated from the other points on the graph. So I will go with this here, 70. See how simple this is? Ooh, what we got here? Question. The scatter plot to the right shows the number of hours of work per week and the number of hours sleep per night for some college student. Does the graph show a strong increasing trend, a strong decreasing trend, or a very little trend? Explained. So I would say this shows very little trend. You can't pick out anything here. And because it shows very little trend, there is very little relationships between work hours and sleep hours here. So it doesn't seem to be related. The number of hours of work does not seem to be related to the number of hours of sleep for these students. Okay, I'm going to leave this one for you. This is from the notes, and let's end this right now. Yeah.